Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in arithmetic sequences and write their corresponding sequence equations, how to find a given term for an arithmetic sequence, how to recognize patterns in geometric sequences and write their corresponding sequence equations, how to find a given term for a geometric sequence, and how to convert an arithmetic and geometric sequences between explicit and recursive forms. How are we learning it? Through the "Oh, I see what you did there" part 1 notes and the "Oh, I see what you did there" part 1 assignment. When can we use this information? To recognize patterns in order to recognize trends in the stock market or housing rates, and to re-examine issues in your life in different ways so that you can find the most appropriate way of solving the problem. How do you know you learned it? By getting a score of 4 on the "Oh, I see what you did there" part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the "I see what you did there" part 1 notes. And then I'll give you time to complete the "Oh, I see what you did there" part 1 assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your "Before You Go." Your only homework for tonight is to continue working on the arithmetic and geometric sequences study guide and any incomplete assignments that you may have. Let's take a look now at the "Oh, I see what you did there" part 1 notes. The notes begin with the learning goals and success criteria. What is an arithmetic sequence? An arithmetic sequence is a sequence of numbers in which each term is found by adding the same number to the previous term. So an example of this would be 2, 4, 6, 8, 10, etc. So each time we move from one to the next, we're adding 2 to it. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, and so on, and it goes on forever. Notice that there's a common difference of 2 between each term in the sequence. So let's take a look at the table. So we have our months, and we look and see that there is a steady change. We're adding by 1 month each time. And in rainfall, we can see that we have a consistent change also. We are adding by 2 inches each month. Therefore, if we were to plot these points, it would look like this, and therefore we can see it does form a straight line, and yes, it is linear because we have a consistent change of addition and a consistent change of addition. So predicting a pattern, so if we're given the pattern of 2, 4, 6, 8, 10, and we're asked, what is the common difference? Well, we should notice that every time we go up 2, so the common difference is 2. So the question is, what would be the next term in the sequence? So after 10, what would be the next one? So we know that we're going up by 2 each time. So we add 2 and we get 12. So the next term would be 12. Again, we have a situation where we know the common difference is 2. Now, what if I asked, what is the 8th term? So we have 1 term, 2, 3, 4, 5. So we need 3 terms later. So we're going to go ahead and add 3 terms. So we add 2 and 2 and 2, and we get 16. So we know that the 8th term would be 16. Now, is that always easy to find? No, depending on the term, we don't want to have to keep calculating out. So the easiest way to do this is to write it in explicit form. So the explicit form for an arithmetic sequence is a to the n, meaning the value that we're trying to find, is equal to d, the common difference, times the number that we want, minus 1, plus the first term in the sequence. So an is the term we're trying to find. So for instance, a7 is the 7th term in the sequence. D is the common difference. N is the number of the term that we're trying to find. And A1 is the first term in the sequence. So let's look at an example. We have a pattern here, 2, 4, 6, 8, 10. The explicit form then is AN is equal to D times N minus 1 plus A1. Well, we know D and we know A1. So we know D is 2, that was the common difference. And A1 is 2 because that's the first term in the sequence. Now let's take a look at this one. So we're given that AN is equal to 3 times n minus 1 plus 4, and we want the 5th term. So 3 is our common difference, 4 is our first term, and we want the 5th term. So we're just going to plug 5 in for n. So this becomes A5 is equal to 3 times 5 minus 1 plus 4. Now we're just solve it. So 5 minus 1 is 4. So we're left with 3 times 4 plus 4. Well, 3 times 4 is 12 plus 4 is 16. So the fifth term in that sequence would be 16. So look at another example. Let's try to find the 10th term of this one. That's an is equal to negative 4 times n minus 1 minus 3. So again, we plug in 10 for n. So this becomes a10 is equal to negative 4 times 10 minus 1 minus 3. Well, 10 minus 1 is 9. So we have negative 4 times 9 minus 3. Well, negative 4 times 9 is negative 36 minus 3. Negative 36 minus 3 is negative 39. So the fifth term in that sequence is negative 39. There's a video here that shows you how to find the common difference for an arithmetic sequence using Symbol Lab. So you can watch that video. Let's take a look now at how we can find a common difference from an arithmetic sequence. So we went to Symbol Lab and went to their arithmetic sequence calculator. And we're going to go here to where it says common difference. And it asks, what's the sequence? So we're going to put in the first 2 or 3 terms. So if it's given as an equation, that's okay. We'll just figure out what the first couple terms are. So let's say it's 3, 7, and 11. So that's our sequence. And we can go ahead and click go. And it will tell us everything we need to know. So it'll write out the equation for us. This is what it should look like in the equation. And it tells us D what the difference is. The difference is 4. So this is how we can use Symbol Lab to find the common difference for our arithmetic sequences. There's a video here that shows you how to find a given term in an arithmetic sequence. So you can use this to check your work. So you can go ahead and watch this video. Let's take a look now at how we can check our work using Symbol Lab to find a given term in an arithmetic sequence. So we go to Symbol Lab and we go to the arithmetic sequence calculator, and we're going to click on the one that says value given index. So I'm going to click on that one, and it asks us for the sequence. Now it prefers to receive the sequences in terms of numbers. So if they give you the equation, that's okay. Just find the first 2 terms. That's all you really need. So I'm going to go ahead and put in the first term as 2 and the second one as 7. And then I'm going to put in the term that I'm looking for. So let's say I'm trying to find the 9th term. So I'm going to go ahead and enter that in, and I click go. And if I scroll down, it gives me the equation here that I'm looking for. And then it computes it for me and tells me that the 9th term should be 42. So this is how I can check my work using Symbol Lab when trying to find a given term of an arithmetic sequence. What is a geometric sequence? A geometric sequence is a sequence of numbers in which each term is found by multiplying the same number to the previous term. An example of this would be 2, 4, 8, 16, 32. What you should notice is every time we move from one term to the next, we have a common ratio or a multiple of 2. So we're multiplying 2 times 2 to get 4. 4 times 2 is 8. 8 times 2 is 16, and so on. How can we recognize exponential functions from a table? Well, first of all, the rule is the number of months, my x values, should be changing by a consistent amount, and it should be addition. And my y values should be changing by multiplication. So in this case, we have the months. So this is 1, 2, 3, 4. Well, is there a steady change in the number of months? Yes, there is, and it's changing by 1 month each time. Now here we have 2, 4, 8, 16. There is a steady change, and it is multiplication. We're multiplying by 2 each time. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we're seeing a steady change, and it's multiplication. It is doubling, or multiplying by 2 each month. So therefore, is this exponential? Yes, it is. And if we were to plot these points, it would look something like this and form this curve. So we're given this pattern, 2, 4, 8, 16, and 32. And we want to know what the common ratio is. Well, we already talked about it earlier. Our common ratio is 2, and we found it by dividing this number by this number. So 4 divided by 2 is 2. So that's our common ratio. So what would the next term be? Well, we would take 32 and multiply by 2, and we get 64. So 64 would be our next term. Again, let's look at another example. What is the common ratio? We know that the common ratio is 2. Now, what would the 8th term be? Well, this is the 1, 2, 3, 4, 5 term. So we need to multiply by 2 3 more times. So this is 32 times 2 times 2 times 2. When we multiply that all out, we get 256. So our 8th term would be 256. Now let's talk about the explicit form for a geometric sequence. The explicit form looks like this. an is equal to a1 times r to the n minus 1 power. An in this case represents the term we are trying to find. For instance, a7 would be the 7th term in the sequence. R represents the common ratio. N represents the number of the term that we're trying to find. And A1 represents the first term in the sequence. So if we're given a pattern here, 3, 6, 12, 24, 48, we go ahead and fill this in. So AN we don't know. We do know A1 and we do know R. So AN is equal to, the first one is 3, and the R value we're multiplying by 2 each time, so R is 2. So this becomes 3 times 2 to the n minus 1. Now let's take a look at an example. We have AN is equal to 3 times 2 to the n minus 1, and we want the 5th term. So we're going to take that and we're going to plug 5 in for n. So this is A5 is equal to 3 times 2 to the 5 minus 1 power. Well, we know that 5 minus 1 is 4. So we have 3 times 2 to the 4th power. Well, 2 to the 4th power is 16. Then we multiply that by 3 and we get 48 is our answer. There's a video here that you can watch on how to check your work when trying to find the common ratio for a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to find the common ratio of a geometric sequence. So we're going to go to symbolab.com and then we're going to find where it says Geometric Sequence Calculator. And I'm going to click here where it says Common Ratio. And it asks for the sequence. Let's say our sequence is 3 and 9 and then 27. So those are the 3 that we know. I'm going to go ahead and click Go. And it will tell me the equation right here. So it tells me exactly what the equation is. It should be a sub n is equal to 3 times 3 to the n minus 1. And it tells me exactly what my r, or my common ratio, is. My common ratio is 3. So this is how I can use Symbolab to find the common ratio of a geometric sequence. There's a video here that shows you how to check your work when trying to find a given term of a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to check our work when trying to find a given term of a geometric sequence. So we're going to go to symbolab.com and then we're going to go to the Geometric Sequence Calculator. And then down here I'm going to go to the one that says Value Given Index. And we're going to enter our sequence. Now, you may have the sequence been given to you as an equation. That's okay, just fine, like the first 2 terms, that's all you really need. So let's say the first term was 4 and the second term was 18. And the term we want is the 7th term. So we just enter our sequence in here and put our index here. Index is the term we want. And we're going to go ahead and click Go. And when we scroll down, it tells us exactly what our ratio is and exactly what our term should be. So our 7th term should be 531,441 over 16. So this would be our solution. So that's how you can use Symbolab to check your work when trying to find a given term of a geometric sequence. Now, how can we predict the next term in a sequence? So let's say we know the 20th term. How do we know then what the 21st term would be? So the way this works is we're going to find the next term in the sequence if the previous term is 57, given that an is equal to an minus 1 plus 4. So what we're saying is the term we want is equal to the previous term plus 4. So we know the previous term is 57. So we're going to plug that in for this one that represents the previous term. So we have 57 plus 4 is equal to 61. So that's how we use the recursive formula to find the next term. Now let's take a look at the recursive form for a geometric sequence. So that follows this pattern. an is equal to r times a to the n minus 1. Now, what we're really saying here is the term we're trying to find is equal to the common ratio times the previous term. So if we look at this one, we have an is equal to 4 times negative 1/2 to the n minus 1. And we want the fourth term. So we start here, and we're going to plug in 4 for n. And we get negative 1/2 to the third power. Well, when we multiply that out, we recognize that negative 1/2 to the third power is equal to negative 1/8. We multiply that by negative 4, and we get positive 1/2. So that would be the term that we're looking at. So let's look at an example here of working with recursive formulas. So we have an is equal to 3 times a to the n minus 1. And we know that the previous term is 21. So we plug 21 in here. So we get an is equal to 3 times 21. Well, we know that 3 times 21 is 63. So an is equal to 63. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the I see what you did there, part 1 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click start the activity. The assignment begins with the learning goals and success criteria. We'll go ahead and click next. It says assignment overview. In this assignment, we will be looking at arithmetic and geometric sequences. We will examine the given terms in order to write the explicit formula that can represent the sequence in order to find any term in the sequence. So let's look at this one. We have a1 is equal to 2 and a4 is equal to 8. And we want to know what is the common difference. Well, let's try some examples. So we have a1 equals 2. So if we add 1 to that, we get a1 would be 2, then 3, 4, 5. So a4 would be 5. So it's not 1. Let's try 2. 2, 4, 6, 8. That works perfectly. So my common difference is 2. So now I'm going to write my equation. So our equation is an equals the common difference times n minus 1 plus a1. So my common difference is 2 times n minus 1, and then plus a1, which is 2. So that goes there. Then I'm going to solve for the 20th term. So I'm going to put 20 in for n. So 20 minus 1 is 19. So then we have 2 times 19 is 38, plus 2 is 40. And then we'll do the same thing for the 30th term. Then you'll do that exact same process for this sequence here. And then we'll go ahead and click next. Then it says within this sequence, we're given that A4 is 8 and D is 5. So it says, what is the first term? So we're going to subtract 5. So if we subtract 5, we get 3. That's A3. Then we subtract 5 again, we get negative 2. That's A2. Subtract 5 again, we get negative 7. So that would be my first term. So now I just plug in my equation. So my common difference is 5 times n minus 1. And my A1 is negative 7, so minus 7. Then I'm going to find the 15th term. So that goes here. So I plug 15 in for n. So I have 15 minus 1 is 14. So 5 times 14 is 70. So 70 minus 7 is 63. So that goes there. You'll do the same thing to find the 23rd term. And then you'll do that same process here for this one. Then we'll click Next. Here it says, this is the equation we came up with. We need to change this to look more like an actual function. So we're going to change this to be y and this to be x. And notice now it creates a graph. So we have our equation here. We have our solution that we came up with for the 20th term for the first one. And notice it forms a graph. We're going to check our work to make sure that we did this right. So when x was 20, y was 40, which is exactly what we said it should be. And it says, what do you notice about the graph of the arithmetic sequence? Well, if we check the graph, we can see that it forms a linear function. So you'll just state that in words. Then we'll go ahead and click Next. Now we're going to look at geometric sequences. So it says, what is the common ratio? So we have A1 is equal to 2 and A4 is equal to 54. Well, let's try 2 for example. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's not 2. Let's try 3. Well, 2 times 3 is 6, times 3 is 18, times 3 is 54. So that's my common ratio, so it's 3. Then I'm going to write that as an equation. So when I do this, I have my an is equal to a1 times r to the n minus 1 power. So let's go ahead and enter that in. So we have a1 is 2 times the common ratio, which is 3, to the n minus 1 power. So just like that. Then it says find the 20th term. Well, I'm going to plug 20 in for n and then solve. So you'll do that for that one and then do it again for the 30th term. So I put 30 in here and solve. Then I repeat the same process over here for the common ratio of this one. Then I click Next. Now this one gives me the common ratio and asks me to find A1. So the first term, we got to figure it out. So we're going to take 8 and divide by 5. So 8 divided by 5 is 8 over 5. Then we do it again and we get 8 over 25. So that's A2. Then we do it again and we get 8 over 125. That would be my first term. Then I go ahead and plug that in. So this is 8 over 125 times the common ratio, which is 5, to the n minus 1 power. And then I'm going to find the 15th term by plugging 15 in for n. And then do it again for the 23rd term by plugging 23 in for n. Then I repeat the whole process over here on this side. Then I click Next. This time it gives me an equation that I came up with. So I'm going to put this as y and this is x, just like before. It says that my 20th term should show up here. Well, we didn't actually do that one together, so it's not showing up. But once you find the 20th term for that first sequence, it'll show up here. And then notice it creates a graph. And it asks, what do you notice about the graph of the geometric function? Well, you should notice that it's an exponential function. So you'll go ahead and put that into words. Now, once you're done with this activity, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.